Hi everyone, my name is Lydia and this is what I wish they taught me about econometrics and introduction. Before we apply the F-test in examples, we need to understand two practical things: how to read the F-table and also understand that the F-test is actually a one-sided test. Once this is clear, doing t-tests or joint hypothesis testing is going to become a lot more easier. So let's do that by kind of understanding what kind of statistic is the F statistic. The F statistic is a ratio of two variances. And as you know, variances, so variance of any x is greater or equal to 0, okay? Which means that the F statistic itself is going to always be greater or equal to 0. Because remember, the F statistic was the ratio of explained variation per regressor to the unexplained variation per degree of freedom. Now, since the F statistic can never be negative, it means that its distribution is going to start at 0 and it also has a long right tail. So if we were to draw and if you were to look any tables that are given to you for the F distribution, you'll see that it starts at 0 here and it has like a very long tail in here. Okay. Keep in mind that large values of F, so any F values will be in here, any large values of F will be in this direction, which means that the larger the F comes, the explained variation will be larger relative to the unexplained variation. Okay, that's why the rejection region in here can only be found in the right tail. And that's why also the F-test is one-sided. Now, what rejecting means for the F-test? Keep in mind, for the F-test, usually small values compared to a critical value will mean no evidence against the null hypothesis, while large values means that there is evidence against the null hypothesis. Keep in mind that most of the times it's going to be very obvious when your F is like extremely large and you will very clearly reject the null hypothesis. However, there's no specific rule of thumbs that you can take, like the 196 or 253 or 164, the same way that you do with the t statistics. And that's the case especially because for the F table, you're not going to have one unique F table. You're actually going to have an F table for every significance level. And while the numbers might be similar, they are not exactly the same. And there might be differences between them. So you have to always be careful that you're picking the table that is giving you the F values at the particular significance level that you have chosen. Okay? So let's have a look at like what an actual F table would look like. This is just an example, and you will notice right away that you have 2 degrees of freedom in here. That is because the F test usually comes with 2 parameters, so the first degree of freedom and the second degree of freedom in here. The first degree of freedom is that of the numerator, the second degree of freedom is that of the denominator in the formula. And given the legend of this table, the numerator is any column that you see in here, while the degrees of freedom for the denominator are all the numbers that you see in the column here, which means that you have to look at the rows one by one here. Evidently, the final F value that you're going to find is where these like column and row intersect. So for instance, if we had to find the F statistic for degrees of freedom 2 and let's say 15, then first we'd have to look at the column corresponding to 2 for the first degree of freedom. Then we'd have to look at line where the degrees of freedom are 15 right here. So that means the place where these intersect is the number here, 7.70. Now keep in mind, this is again the F statistic for degrees of freedom 215 for a level of significance of 0.5% in here, which means that you would have to look at another table if you want the 5% instead, and the value is going to be slightly different. Typically, the tables that you find most commonly are those for 10%, 5%, 1%. But keep in mind that just as we did for any of the values in the t-test, we can find also for the f-test. The only difference that we are clearly seeing between the t-table and the f-table, though, is that while in the t-table, given a t statistic, we could find the p-value associated to it, in the particular case for the f distribution, we can find only the f value for a particular level of significance. So we can't do the conversion of like having the p-value associated to it and then directly find the f statistic, because as I said, we're going to have multiple tables that we're going to have to scour through. Okay. So just once again, as a recap, in order to read the F table, you need 2 degrees of freedom. So numerator degree of freedom, which is the number of restrictions, and denominator degrees of freedom, which is the residual degrees of freedom, the n minus k minus 1. And that's why the F table basically looks two-dimensional like this. In terms of decision rules, so once we have found the F from this table, so let's say the F star has been calculated by our formula and gives us a certain number. From the table, we get the F critical at a certain level of alpha. In order for us to make a decision, we literally have to compare these two values. And the rule will stay exactly the same, what we learned with the t statistic, if the f star, the ones that we calculate, is bigger than the f critical that we find in the table. That means that we reject the null hypothesis. Otherwise, we don't have enough evidence to reject the null hypothesis. Keep in mind, for the F distribution or the F test, there's no symmetry, no left tail, so no two-sided adjustments that you need to make. The F test is a one-sided test because it tests whether explained variation is large enough compared or relative to unexplained variation, and that happens in the right tail. Now that you know how to read an F table and why the tests that you're going to see from now on are one-sided tests, you're ready to look into an example, which is what will happen in the next video. So stay tuned and I'll see you then.